How one secret torpedo fix saved American subs. Then Japanese admirals panicked, December 10, 1941. Pearl Harbor Naval Base, territory of Hawaii. The water still stinks of oil and death. 3 days after the attack, the harbor is a graveyard of twisted steel and broken hulls. The USS Arizona lies entombed beneath the surface, her crew forever sealed within. Smoke still rises from the wreckage like incense for the fallen. In a makeshift command center, a Japanese naval intelligence officer named Commander Takeo Nakamura reviews reconnaissance photographs. He smiles as he shuffles through images of shattered battleships, capsized destroyers, burning aircraft. His aide, a young lieutenant, points to a report. "Commander, American submarine activity has increased in our shipping lanes." Nakamura waves his hand dismissively, lighting a cigarette. "They're submarines?" He laughs, a short, sharp bark. "Let them come." "Their torpedoes are toys, defective toys. We've intercepted their reports. Half don't explode. The others run too deep or circle back like confused children." He taps ash onto the photographs of sunken American warships. "The Americans lost their battleship fleet in one morning. Now they send submarines with broken weapons into waters we control. It's not a threat, Lieutenant. It's suicide dressed as strategy." The lieutenant nods, though something in his eyes suggests uncertainty. Nakamura leans back, exhaling smoke toward the ceiling. "Tell our convoy commanders to maintain standard protocols. American submarines are an irritation, nothing more, like mosquitoes with bent stingers." He returns to his reports, confident, comfortable, certain. Outside, in the shipyards of Mare Island, California, and Portsmouth, New Hampshire, American submarine crews load Mark 14 torpedoes into their boats with prayers and curses. They know what awaits them. Japanese convoys protected by destroyers, depth charges that shake submarines like toys in an angry child's fist, and weapons that betray them at the moment of truth. But something else is happening in those same shipyards. In dimly lit workshops and testing facilities, engineers are beginning to understand. They're finding the invisible cracks in the system. They're discovering why good men die with working weapons that refuse to work. And they're about to fix it. What Commander Nakamura didn't know, what no one in the Imperial Japanese Navy could have predicted, was that the very torpedoes he mocked would soon become the instrument of Japan's strangulation. The defective toy was about to become a butcher's blade, and the mosquitoes with bent stingers were about to drain an empire of its blood. The Mark 14 torpedo was supposed to be America's masterpiece. Developed throughout the 1930s by the Naval Torpedo Station in Newport, Rhode Island, it represented the cutting edge of underwater warfare technology. 20 feet long, weighing 3,280 pounds, capable of carrying a 643-pound Torpex warhead at speeds up to 46 knots for distances exceeding 4,500 yards. The engineers were proud. The torpedo featured the revolutionary Mark 6 magnetic influence exploder, a secret device so classified that even submarine commanders weren't told how it worked. The theory was elegant. The torpedo didn't need to hit a ship. It would pass beneath the hull and detonate when it sensed the change in the Earth's magnetic field caused by the steel ship above. One torpedo, one kill, no wasted shots. The concept was German in origin, captured and reverse-engineered from World War I designs. American engineers refined it, perfected it, made it their own. But there was a problem. Several problems, actually. Problems that would kill American submariners, waste irreplaceable torpedoes, and nearly lose the Pacific War before it truly began. Problem 1. They never really tested it. Live fire testing was expensive. Each Mark 14 torpedo cost $10,000, equivalent to $200,000 today. During the Depression-era 1930s, the Bureau of Ordnance, BUORD, conducted exactly 2 live fire tests of the magnetic exploder. 2 tests. For a weapon system that would be expected to sink the Japanese merchant marine and the Imperial Japanese Navy. The torpedoes performed adequately in those 2 tests. BUORD declared the weapon operational and sent it to the fleet. No testing in tropical waters, where magnetic fields differ from Newport, Rhode Island. No testing at combat depths or speeds. No testing with the actual impact exploder that would be used if the magnetic system failed. Just 2 shots, a thumbs up, and a production order for thousands of units. Problem 2. The depth control was a lie. The Mark 14 was designed to run at a preset depth, controlled by a complex mechanism involving a hydrostatic valve, a pendulum, and a depth engine that adjusted the torpedo's horizontal fins. Set it for 10 feet, and it should run 10 feet below the surface. Except it didn't. The torpedo consistently ran approximately 11 feet deeper than its depth setting indicated. This was due to a fundamental design flaw. The pressure chamber that sensed depth was located in the nose, but the guidance mechanism calculated depth based on the chamber's position relative to the torpedo's center of gravity. As the torpedo accelerated and angled slightly nose down, the sensor read artificially high pressure, causing the depth engine to steer the weapon deeper than intended. This meant that magnetic exploders designed to pass 3 feet under a keel were actually passing 14 feet under, too far for the magnetic field to trigger detonation, and direct hits aimed at a ship's waterline struck harmlessly below the armored belt if they struck at all. Problem 3. The contact exploder was a catastrophe. If the magnetic exploder failed, or was deactivated, the torpedo reverted to a backup, the Mark 6 contact exploder, which was supposed to detonate on physical impact. It was based on a 1920s design that had never been adequately tested at the oblique angles that occur during actual combat approaches. The firing pin mechanism was held in place by a thin metal pin. Upon impact, inertia was supposed to shear this pin, releasing a spring-loaded striker that would hit the detonator. But when a torpedo hit at anything other than a perfect 90-degree angle, which was almost always, the force of impact would bend or jam the firing mechanism before the pin could shear. The torpedo would strike the target with tremendous force, the warhead would remain intact, and the torpedo would either sink uselessly or, worse, circle back toward the submarine that fired it. Submariners called them duds. They had more colorful terms, too, most unprintable. Problem 4. Institutional arrogance. The Bureau of Ordnance, the Navy bureaucracy responsible for all weapons, refused to believe there was a problem. When submarine commanders returned from patrol with stories of torpedoes that ran too deep, exploded prematurely, or failed to explode at all, Buord blamed the submariners. Incorrect depth settings, improper maintenance, poor attack geometry, operator error. The submarine force, still reeling from peacetime attitudes where career advancement meant avoiding controversy, initially accepted these explanations. Some didn't. Some protested. Some documented failures meticulously. They were ignored. One commander, Charlie Lockwood, kept detailed logs of every torpedo fired, every malfunction, every failure. He compiled statistics, wrote reports, demanded investigations. Buord responded by questioning his competence. The institutional response was clear. The weapon is perfect. The warriors are flawed. The result, December 1941 to mid-1943. American submarines went to war with a weapon that didn't work. In the first 18 months of the Pacific War, U.S. submarines fired thousands of torpedoes at Japanese targets. Hit rates were abysmal, somewhere between 10% and 15%. Even when torpedoes hit, they frequently failed to explode. The USS Tinosa, under Commander Dan Daspit, fired 15 torpedoes at the Japanese tanker Tonen Maru No. 3 in July 1943. The ship was stopped, dead in the water, a sitting target at close range. 11 torpedoes struck the hull, 2 exploded, 9 hit with metallic clangs and fell away harmlessly. Daspit, furious and heartbroken, kept 1 torpedo in reserve and returned to Pearl Harbor. He demanded that Buord test the weapon to failure. They finally did. The USS Scamp ambushed a Japanese convoy and fired 10 torpedoes. Not one exploded. The USS Growler attacked a cruiser at point-blank range. 4 hits, 0 explosions. The USS Trigger fired 8 torpedoes at a tanker. The crew heard the impacts echoing through the water, metallic thuds like hammers on an anvil. The tanker steamed away unharmed. Submariners began rationing torpedoes, firing fewer shots per target, knowing that most would fail. This made attacks even more dangerous, requiring closer approaches, longer exposures to enemy escorts, higher risks of counterattack. Men died because their weapons didn't work. Ships that should have been sunk escaped. Convoys that should have been devastated reached their destinations intact. And the Japanese, initially wary of American submarines, began to relax. But deep in the maintenance shops and testing facilities, a handful of stubborn men refused to accept failure. They began tinkering, questioning, testing, and slowly, too slowly for the men dying in iron coffins beneath the Pacific, they began to understand. The weapon wasn't perfect, it was broken, and they were going to fix it. No one imagined that this apparent failure carried the seed of total victory. No one except the submariners who refused to give up. January 27, 1942, South China Sea off Cam Ranh Bay, Indochina. The USS Swordfish sits at periscope depth, 800 yards from a Japanese seaplane tender, the Sanyo Maru. Commander Chester Smith watches through the periscope as the target moves across his crosshairs. Perfect setup, perfect geometry. The shot is gift-wrapped. Fire one, The submarine shudders slightly as compressed air expels the first Mark 14 torpedo. Fire 2! Another shudder. Through the periscope, Smith watches the wake streak toward the target. The torpedoes are running hot, straight, and normal. The crew holds its collective breath. Impact in 20 seconds, 15 seconds, 10 seconds. The torpedo wakes disappear beneath the hull of the Sanyo Maru. 5 seconds. Nothing. The torpedoes pass completely under the target and continue into the distance until their fuel is exhausted. Smith's jaw tightens. Fire 3! Fire 4! 2 more torpedoes leap from the tubes. 2 more wakes arrow toward the oblivious seaplane tender. Two more passes underneath the keel. 2 more failures. Smith slams his fist against the periscope housing. God damn it! The executive officer, pale and confused, checks the torpedo data computer. Sir, solutions were perfect. Depth set at 10 feet. The ship's draft is 15 feet. They should have hit. Should have, Smith repeats bitterly. Add that to the fucking report. The swordfish breaks off the attack before Japanese escorts can locate her. Smith surfaces that night and sends a terse message to Pearl Harbor. Fired 4 torpedoes at stationary target. Perfect setup. 0 hits. Torpedoes ran beneath keel. Possible depth control failure. Request investigation. The response from Pearl Harbor comes 12 hours later. Check torpedo maintenance procedures. Verify depth settings. Continue patrol. Smith reads the message twice, then crumples it. They think we can't set a fucking depth gauge. February 14th, 1942. Off Truck Lagoon, Caroline Islands. The USS Trout stalks a Japanese aircraft carrier, the Hosho, an older vessel, but still a prized target. Commander Frank Fenno maneuvers into perfect position, 200 yards, a textbook approach. He fires a spread of 4 torpedoes. The first detonates prematurely, 300 yards from the target, alerting every escort in the formation. The second torpedo explodes halfway to the target, another premature detonation. The third and fourth torpedoes pass under the carrier's keel without exploding. Depth charges rain down on the Trout for the next 3 hours. The submarine survives, barely, limping back to Pearl with cracked gauges and traumatized crew. Fenno's report is scathing. Magnetic exploders are unreliable. Premature detonations compromise attack and endanger boat. Recommend immediate deactivation. Buord's response: magnetic exploder is functioning as designed. Premature detonations likely caused by rough handling during loading or improper attack profile. Exploders will remain active. March 8, 1942. Off Java, Dutch East Indies. The USS Seawolf attacks a Japanese cruiser at dawn. Commander Frederick Warder fires 8 torpedoes in a carefully calculated spread. 5 explode prematurely. 2 run erratically, 1 circling back toward the Seawolf, forcing an emergency dive. One strikes the cruiser amidships. A solid, metallic clang echoes through the water, but doesn't explode. The cruiser, alerted and angry, launches a counterattack that drives the Seawolf to test depth, where hull plates groan and rivets weep seawater. Warder surfaces that night and transmits, "Fired 8 torpedoes, 0 effective hits. Weapon system is fundamentally flawed. Urgent investigation required." The response: "Continue patrol. Maintain weapons protocols. Investigation ongoing." There was no investigation. The pattern was undeniable. By mid-1942, American submarine commanders had identified three distinct failure modes. Failure Mode Alpha, depth control. Torpedoes set to run at 10 feet were actually running at 21 feet or deeper, passing harmlessly beneath targets. Failure Mode. Bravo, magnetic exploder. Torpedoes equipped with magnetic exploders either detonated prematurely, sometimes at the moment of firing, or failed to detonate at all, even when passing directly under enemy keels. Failure Mode. Charlie. Contact exploder. Torpedoes that struck targets at oblique angles failed to detonate, their contact exploders jamming or failing to trigger. Submarine commanders began keeping private logs, documenting every failure with clinical precision. They compared notes during rest periods in Pearl Harbor and Brisbane, piecing together the systemic pattern that Buord refused to acknowledge. Commander Charlie Lockwood, appointed Commander Submarine Force Pacific, COM Subpac, in early 1943, made it his personal mission to fix the torpedo crisis. He collected data from every boat, every patrol, every attack. The statistics were damning. Total torpedoes fired, December 1941, June 1943, 1,400 plus. Estimated hit rate, 11%. Estimated dud rate among hits, 35–40%. Effective kill rate, 7%. Out of every 100 torpedoes fired, only 7 did what they were designed to do. The other 93 were worse than useless. They gave away the submarine's position, wasted irreplaceable munitions, and killed American credibility with Allied commanders who wondered why U.S. subs were so ineffective compared to their German counterparts. The British Royal Navy, reviewing American patrol reports, sent a diplomatic but pointed message. Request clarification on reported torpedo performance. Our analysis suggests mechanical deficiency rather than tactical error. Even the Allies were politely calling bullshit. But Buord held the line. Rear Admiral William Spike Blandy, chief of the Bureau of Ordnance, refused to admit fault. In an internal memo dated April 1942, he wrote, "The Mark 14 torpedo represents the finest underwater weapon in the world. Reports of malfunction are exaggerated and reflect inadequate training and poor maintenance standards in the submarine force. Any modifications to the magnetic exploder would compromise its effectiveness and waste taxpayer resources. This matter is closed." The matter was not closed. In Pearl Harbor, in Brisbane, in the cramped forward torpedo rooms of submarines returning from failed patrols, anger was building. Submariners, men who volunteered for the most dangerous service in the Navy, were dying not because the enemy was superior, but because their own weapons betrayed them. The SS Wahoo, under the legendary Mush Morton, attacked a Japanese convoy and scored multiple hits on a transport. The transport didn't sink. Morton surfaced, a dangerous and desperate move, and tried to sink the ship with his deck gun. It took 46 rounds of 4-inch ammunition to finish what one torpedo should have accomplished. Morton returned to Pearl, walked into Admiral Lockwood's office, and slammed his patrol report on the desk. Admiral, I'd rather fight the Japanese with my bare hands than with these goddamn torpedoes. At least my hands work. Lockwood picked up the report. He'd read dozens like it. He looked at Morton, a man who'd become a legend for his aggression and skill, and saw defeat in his eyes. Not defeat by the enemy, defeat by institutional incompetence. Give me time, Mush. We're going to fix this. How much time, sir? How many more patrols? How many more men? Lockwood didn't have an answer. Not yet, but he would. Because in a testing facility in Pearl Harbor, a maverick torpedo officer named Jim Campbell was about to conduct an unauthorized experiment. An experiment that would prove what everyone already knew. And once the proof was undeniable, even Buord couldn't hide behind procedure and protocol. The truth was about to surface, and with it, a weapon that would turn the tide of the Pacific War. June 20th, 1943. Pearl Harbor Submarine Base, Torpedo Testing Facility. Lieutenant Commander Jim Campbell stands on a wooden dock, staring at a fishing net suspended beneath the surface of a test basin. The net hangs exactly 20 feet below the waterline, measured and verified 3 times. Beside him, Chief Torpedo Man Ed Taylor checks his notes. Settings confirmed, sir. Depth set at 10 feet. New torpedo, fresh from assembly. Hydrostatic valve tested and certified. Campbell nods but says nothing. This is an unauthorized test. Not forbidden exactly, but not approved either. Campbell is operating in the gray zone of initiative that separates good officers from great ones. He's using his own time, his own resources, and if he's wrong, his own career. But he's not wrong. He knows he's not wrong. Fire when ready, Chief. Taylor signals the test crew. A pneumatic impulse launches a Mark 14 torpedo from a stationary tube. The weapon enters the water cleanly, motor whining as it accelerates. Campbell watches through binoculars as the wake moves across the test basin. The torpedo passes through the area where the net is suspended and hits it, not above the net. Not near the net. Directly into the net, tangling in the mesh like a fish caught by its own kind. Taylor wades into the shallow water and examines the net. Contact at 21 feet, sir. 11 feet deeper than depth setting. Campbell writes the number in his notebook. Set another one. Depth at 5 feet this time. They fire 4 more torpedoes over the next 2 hours. Every single one runs approximately 11 feet deeper than its depth setting. Set at 5 feet, runs at 16 feet. Set at 15 feet, runs at 26 feet. The pattern is consistent, repeatable, undeniable. The Mark 14 torpedo depth control mechanism is systematically wrong. Campbell's hands shake as he writes the final calculations. 11 feet deeper on every shot, which means that every torpedo fired in anger over the past 18 months has been running beneath its target, passing harmlessly under keels, missing contact points, wasting attacks. Jesus Christ, Taylor whispers. Every boat, every patrol, every shot. Campbell looks up from his notes. Not anymore. June 24th, 1943. Admiral Lockwood's office, Pearl Harbor. Campbell presents his findings to Admiral Charles Lockwood, accompanied by Commander Lawson Red Ramage, one of the most aggressive and successful sub-captains in the fleet. Lockwood listens without interrupting, his face carved from stone. When Campbell finishes, Lockwood leans back in his chair. You conducted these tests without authorization. Yes, sir. Using live torpedoes from our operational inventory. Yes, sir. And you're telling me that every submarine in this fleet has been firing weapons that run 11 feet deeper than we think they do? Yes, sir. The depth control mechanism has a fundamental design flaw. The pressure sensor is located in the nose, but... Lockwood holds up a hand. I understand the engineering. What I need to know is, can we fix it? Immediately, sir. We can offset the depth settings by 11 feet. If we want the torpedo to run at 10 feet, we set it for -1 foot. The mechanism will compensate, and the weapon will run at the correct depth. Ramage leans forward. Admiral, if this is true, and I believe it is, we need to inform every boat in the fleet immediately. We've been shooting underneath them for a year and a half. Lockwood nods slowly. Buord will fight this. They'll claim the tests are flawed, that the sample size is too small, that operational conditions differ from test conditions. Respectfully, sir, Campbell says, fuck Buord. Send the directive. If we're wrong, the torpedoes will run too shallow and hit above the waterline. If we're right, Lockwood interrupts, we just gave our submarine force a new weapon. He picks up a telephone. Get me every submarine commander currently in port. I want them in the briefing room in 1 hour. June 25th, 1943. The directive goes out to the entire Pacific submarine fleet. Effective immediately. All Mark 14 torpedoes. Depth settings to be reduced by 11 feet. Example, for target requiring 10-foot depth, set torpedo for -1 foot. Acknowledge receipt. The responses come back within hours. Acknowledged. Request. Confirm. Negative depth settings authorized. Confirmed. Offset accounts for discovered depth control error. Utilize new settings on next patrol. In Brisbane, Australia, Commander Sam Deely of the USS Harder reads the directive and laughs, a sharp, bitter sound. -1 foot. They want me to set the torpedoes to run in the fucking air above the water. His executive officer shakes his head. It's not above the water, sir. The torpedo thinks it's at -1, so it corrects upward. But the correction is 11 feet, which puts it at 10 feet below the surface, right where we want it. Deely stares at the message for a long moment. We've been missing because our own weapons lied to us. Yes, sir. And now we're going to lie back. Yes, sir. Deely grins, a wolf's grin, predatory and cold. I like it. When do we sail? July 4th, 1943. South China Sea off Hainan Island. The USS Harder stalks a Japanese destroyer. Deely has been hunting this particular ship for 3 days, learning her patrol patterns, timing her movements. Now, with the new depth settings programmed into his torpedoes, he's ready. Solution set, range 900 yards, depth setting, -1 foot. The torpedo room crew exchanges glances. Setting a torpedo to run above the water still feels wrong, even though they understand the math. Fire 1. The torpedo leaps from the tube. Through the periscope, Deely watches the wake streak toward the destroyer. 10 seconds. 5 seconds. Impact. The explosion is massive. A column of white water erupts from the destroyer's midsection. The ship lurches sideways, her keel broken, internal bulkheads failing. Deely's eyes widen. Holy shit, it worked. Fire 2! The second torpedo strikes forward of the bridge. The destroyer's bow lifts out of the water, propellers thrashing air. She goes down in less than 3 minutes. Dealey surfaces briefly, confirming the kill, then transmits, "Depth correction confirmed effective." Destroyer sunk 2 hits. Weapon performance exceeds all previous expectations. Request permission to continue hunting. The word spreads. Within weeks, every American submarine in the Pacific is using the corrected depth settings, and suddenly, American torpedoes start working. The USS Tinosa returns to patrol and sinks 3 merchants in 4 days. The USS Wahoo intercepts a convoy and destroys 4 ships in a single night. The USS Flasher ambushes a tanker and watches it erupt in flames from a single perfectly placed shot. Hit rates climb from 11% to 30%, then 40%, then higher. Submarine commanders, previously cautious and frustrated, become aggressive. They know their weapons work now. They trust their shots. The Pacific submarine campaign, previously anemic and disappointing, begins to transform into a slaughter. But the Mark 14 still had problems. The magnetic exploder still detonated prematurely. And the contact exploder still failed on oblique hits. Fixing the depth control was only the first step. 2 more battles remained, 2 more fights against institutional arrogance and engineering failure. But now, the submarine force had tasted success. They knew the weapon could work, and they were done accepting excuses. July 24, 1943, USS Tinosa, off Palau. Commander Dan Daspit stares through the periscope at the Japanese whale factory ship Tonan Maru No. 3, 19,000 tons. Dead in the water, stopped for repairs, a target so perfect it's almost insulting. "This is it," Daspit says quietly. "This is where we prove it once and for all." He fires 15 torpedoes, his entire loadout except for 1. 11 strike the hull. 2 explode. 9 hit with dull metallic thuds and fall away. The Tonan Maru limps away. Daspit surfaces, furious beyond words. He keeps 1 torpedo, the last one loaded in its tube. "Set course for Pearl Harbor, maximum speed." His executive officer stares at him. "Sir, we're breaking off patrol. We're going home, and we're bringing proof." August 1st, 1943, Pearl Harbor. Daspit storms into Admiral Lockwood's office and slams his patrol report on the desk. "I want them to test that last torpedo. Not a simulation, not a calculation. I want them to fire it at a cliff and see what happens." Lockwood reads the report. 11 hits. 2 explosions. "They'll say you hit at bad angles." "Then let them prove it." "Fire the damn torpedo straight at a steel plate. See if it works." Lockwood picks up the phone. "Get me the ordnance testing range. I want a full destructive test of a Mark 14 contact exploder. Today." August 3rd, 1943, Kahulawe Island, Hawaii. A Mark 14 torpedo is fired directly at a submerged steel plate at a perfect 90-degree angle. It hits. It doesn't explode. They recover the torpedo and disassemble the exploder. The firing pin mechanism is bent. The impact, the force that should have triggered detonation, instead jammed the mechanism before the detonator could fire. A second test, this time at a 45-degree oblique angle. Same result. Hit. No explosion. Bent firing pin. The contact exploder, designed in the 1920s, never properly tested, assumed to be functional, has been failing for 2 years. Admiral Lockwood orders the magnetic exploder deactivated fleet-wide. Then he orders the contact exploder redesigned. Engineers strip out the fragile firing pin mechanism and replace it with a simpler, more robust system. The new design is tested 50 times in 3 days. 50 hits, 50 explosions. September 1943, the fix is complete. Depth control, corrected. Magnetic exploder, deactivated. Contact exploder, redesigned and tested. The Mark 14 torpedo, broken for 2 years, is finally fixed. And the Japanese Empire is about to learn what American ingenuity, combined with cold fury, can produce. The age of mercy is over. The age of the submarine wolf pack has begun. October 15, 1943, Luzon Strait, Philippines. The USS Wahoo, under Commander Dudley Mush Morton, intercepts a Japanese convoy, 4 transports, 2 escorts. Morton doesn't hesitate. Battle stations torpedo, all tubes. The new Mark 14s leap from the tubes in quick succession. 6 torpedoes, 6 hits, 6 explosions. The first transport breaks in half, her cargo of troops and equipment spilling into the sea. The second transport erupts in flames, an ammunition ship detonating with enough force to shatter windows on the Wahoo despite being submerged. The third transport capsizes, rolling like a dying whale. The fourth tries to run. Morton surfaces and chases her down with his deck gun, pounding her until she settles beneath the waves. The escorts flee. Morton transmits a terse message. 4 transports sunk, 0 misses, weapon system performs flawlessly, returning to station. On November 8, 1943, Imperial Japanese Navy Headquarters, Tokyo. Vice Admiral Takagi Takeo reviews the loss reports from the past month. The numbers are staggering. October 1943 merchant losses, 42 ships, 190,000 tons, 3 times the losses of September, 4 times the losses of August. He spreads the map across his desk, marking each sinking with a red pin. The map bleeds red. Luzon Strait, 6 pins. South China Sea, 11 pins. East China Sea, 9 pins. Formosa Strait, 8 pins. Every major shipping lane, every critical convoy route saturated with American submarines. Takagi's aide, a young captain, speaks carefully. Admiral, the submarine activity has increased, but the real change is their effectiveness. They're not missing anymore. Every attack succeeds. Every torpedo hits. Our escorts report that American submarines are now attacking on the surface at night, using radar we cannot detect. They close to point-blank range and destroy entire convoys before we can react. Takagi lights a cigarette, his hand steady despite the fury building in his chest. What changed? We don't know, Admiral. Intelligence suggests they fixed a technical problem with their torpedoes. Reports from survivors describe explosions that tear ships apart, much more powerful than the earlier attacks. Their torpedoes always had powerful warheads. The problem was they didn't explode. They explode now, Admiral. Takagi stares at the map. 42 ships in 1 month. At this rate, the merchant marine, the lifeline that keeps Japan's war machine operational, will be extinct within 2 years. Increase escort coverage. Assign more destroyers to convoy duty. Establish aerial patrols over all major routes. Admiral, we don't have enough destroyers. The Americans are sinking them too. Takagi's cigarette burns down to the filter, forgotten. Then we're going to lose. The captain doesn't respond, because the Admiral is right. December 19, 1943, East China Sea. The USS Skate, under Commander Eugene McKinney, detects a convoy through periscope observation. 5 tankers, 4 escorts. McKinney sets up a classic approach, submerged, patient, waiting for the geometry to align. Fire 1 through 6. The torpedoes run hot, straight, and normal. 4 tankers explode simultaneously. The 5th tries to run. McKinney surfaces, a brazen, aggressive move that would have been suicidal 6 months earlier, and fires his stern tubes at the fleeing tanker. 2 hits, the tanker breaks apart, spilling heavy fuel oil across the ocean in a spreading black stain. McKinney watches through binoculars as Japanese sailors abandon ship, swimming through the oil, screaming for help that won't come. He feels nothing, no pity, no remorse. Pearl Harbor was 2 years ago, but the memory is fresh as blood. All ahead full. Clear the area. The skate submerges and disappears, leaving the convoy burning behind her. January 1944. The numbers tell the story. January 1944. Merchant losses, 57 ships, 247,000 tons. February 1944. Merchant losses, 64 ships, 289,000 tons. March 1944. Merchant losses, 71 ships, 312,000 tons. The curve is exponential. The destruction is systematic. American submarines, once a nuisance, have become an existential threat. February 7, 1944. USS Tang, Philippine Sea. Commander Richard O'Kane, former executive officer under Mush Morton, now commanding his own boat, stalks a Japanese carrier escort, the Taiyo Maru. 11,000 tons, escorted by 2 destroyers. O'Kane doesn't care about the destroyers. He closes to 1,000 yards, suicidally close by pre-war standards, and fires a spread of 4 torpedoes. All 4 hit within 3 seconds of each other. The Taiyo Maru doesn't sink. She disintegrates. The explosions are so violent that the shock wave damages the Tang's periscope, cracking the lens and flooding the periscope well. O'Kane surfaces to assess damage, and through binoculars watches the Taiyo Maru disappear beneath the waves in less than 90 seconds. There are no survivors. The destroyers, stunned by the ferocity of the attack, drop depth charges in the wrong location while the Tang escapes at flank speed. O'Kane's patrol report is clinical. Carrier escort destroyed. 4 torpedoes fired, 4 hits, 4 explosions. Target sank in approximately 90 seconds. No counterattack sustained, weapon performance exceptional. But in the margins, in his personal log, O'Kane writes something else. The Japanese thought our torpedoes were broken toys. Now they know better, now they run. March 15, 1944. Imperial Japanese Navy Staff Meeting, Tokyo. Admiral Yamamoto is dead, killed in an ambush over Bougainville. His replacement, Admiral Koga Minichi, presides over a conference table surrounded by exhausted staff officers. The subject, submarine losses. Merchant Marine Status Report. Operational capacity, 68% of pre-war tonnage. Monthly attrition rate, 4.5%. Projected merchant fleet exhaustion, November 1945. A logistics officer stands, his voice flat with resignation. Gentlemen, at current loss rates, Japan will be unable to import sufficient oil, rubber, rice, or steel to maintain military operations by mid-1945. The Greater East Asia co-prosperity sphere is being strangled. Admiral Koga slams his fist on the table. Then sink the submarines. Admiral, we've sunk 23 American submarines since the war began. They've launched 42 new boats in the same period. They're building them faster than we can destroy them. Then build more escorts. We don't have the steel, Admiral, and the submarines are now sinking our destroyers as readily as they sink our merchants. Last week, the USS Harder sank 3 destroyers in 4 days. A single submarine destroyed 3 capital warships. Silence. The kind of silence that precedes surrender or madness. Koga lights a cigarette with trembling hands. What changed? 6 months ago, American submarines were ineffective. Their torpedoes failed constantly. Our convoys reached their destinations. Now every voyage is a death sentence. What changed? No one answers. Because the answer is unthinkable. The Americans fixed their weapons, and Japan has no counter. April 23, 1944, USS Harder, off Tawi-Tawi, Philippines. Commander Sam Dealey has become a legend. His boat, the Harder, has developed a reputation as a destroyer killer, a submarine that hunts the hunters. Today, Dealey spots 3 Japanese destroyers conducting an anti-submarine sweep. They're looking for him. Instead of evading, Dealey does the unthinkable. He attacks. Submerged, he maneuvers into position and fires a spread at the lead destroyer, the Minatsuki. 2 hits. The destroyer explodes, her magazines detonating in a catastrophic chain reaction. The other 2 destroyers converge on Dealey's position, launching depth charges. The Harder dives deep, ribs creaking, light bulbs shattering. Dealey waits, silent, patient, deadly. The destroyers pass overhead, pinging frantically with active sonar. Dealey rotates and fires his stern tubes at the nearest destroyer, the Hayanami. 1 hit. The destroyer breaks in half, her bow and stern rising like twin tombstones before sliding beneath the waves. The 3rd destroyer panics and runs. Dealey surfaces and sends a message that will become famous. Destroyers down, Emperor. Harder returns to patrol. May 1944. The psychological collapse begins. Japanese convoy commanders, previously confident, now report widespread panic. Captains refuse convoy duty. Crews desert. Merchant ships sail alone rather than in groups, preferring to take their chances scattered across the ocean rather than bunched together as targets. But it doesn't matter. The American submarines find them anyway. The USS Flasher sinks the tanker Hako Maru, 10,000 tons of fuel oil gone in a single explosion. The USS Rasher ambushes the escort carrier Taiyo, a fleet carrier pressed into convoy escort duty, and sends her to the bottom with 4 torpedoes. The USS Barb surfaces off the coast of China and shells a railway station, destroying locomotives and supply depots with her deck gun. The USS Archerfish sinks the newly completed carrier Shinano, 70,000 tons, the largest warship ever sunk by a submarine, with 6 torpedoes fired in a single salvo. The Japanese merchant marine is dying. Crude oil imports drop by 60%. Steel imports drop by 75%. Rice imports drop by 40%. Factories close. Airfields run out of fuel. Warships sit in port, unable to sail because there's no fuel oil. The Imperial Japanese Navy, once the most powerful naval force in the Pacific, is reduced to spectator status, watching helplessly as American submarines strangle the empire. June 19, 1944. Battle of the Philippine Sea. The Great Marianas Turkey Shoot. Japanese naval aviation, once the finest in the world, launches a desperate attack against the American carrier fleet. Of 373 aircraft launched, 243 are shot down. The pilots are inexperienced, poorly trained, flying planes built with substandard materials because the factories lack proper steel and aluminum. Why? Because the submarines sank the cargo ships that carried the raw materials. The Japanese lose 3 carriers in the battle. not to American carrier strikes, to submarines. The USS Kavala sinks the carrier Shokaku. The USS Albacore sinks the carrier Taiho, Japan's newest and most advanced carrier. American submarines are now operating with impunity inside Japanese defensive perimeters, sinking capital ships, destroying convoys, laying mines in harbors. The Japanese Navy, designed to fight a decisive surface battle, is being destroyed piecemeal by an enemy they can't see, can't catch, and can't kill. August 1944. Imperial Japanese Navy Strategic Assessment. The report is classified top secret. It will remain hidden in Japanese archives until after the war. Summary of submarine threat. American submarine operations have achieved complete dominance of our maritime supply lines. Merchant losses exceed replacement capacity by a factor of 8 to 1. Naval losses to submarine attack now exceed losses to all other causes combined. Our escorts are ineffective. Our detection equipment is inferior. Our countermeasures are inadequate. The submarine campaign has accomplished what no surface fleet could achieve: the complete isolation of the Japanese home islands from the resources of the Southern Resource Area. Without oil, rubber, steel, and rice, Japan cannot continue the war beyond 1945. Recommendation: negotiate immediate armistice before total collapse becomes inevitable. The recommendation is ignored. The war will continue for another year, but the outcome is no longer in doubt. September 12, 1944. USS Barb, South China Sea. Commander Eugene Fluckey reads the intelligence report with grim satisfaction. Japanese coastal convoy routes now designated as extremely hazardous. Merchant captains refusing duty. Some ships sailing with skeleton crews. Others anchored indefinitely in port. Fluckey looks up at his executive officer. They're not sailing anymore. They're too scared. Yes, sir. They know we're out here. Fluckey nods slowly. Good. Fear is a weapon, too. He plots a course toward the Chinese coast, where the last desperate convoys still try to move supplies under cover of darkness. The Barb will be waiting. She's always waiting. October 1944. The sound of thunder. There is a sound that Japanese sailors learn to fear above all others. Not the roar of aircraft engines, not the boom of naval gunfire. The sound is quieter, more subtle, more deadly. It's the high-pitched whine of an electric motor. The sound of a Mark 14 torpedo running hot, straight, and normal, closing the distance at 46 knots. By the time you hear it, it's too late. Japanese merchant marine losses: 1944, 767 ships, 393,000 tons, 90% sunk by submarines. The merchant fleet, 4.1 million tons at the start of the war, now stands at less than 1.5 million tons. And it's still dying. Japan's economy is collapsing. Her military is starving. Her people are facing famine. And in the dark waters of the Pacific, American submarines continue their work. Silent, patient, merciless. The joke about broken torpedoes is no longer funny. It stopped being funny somewhere between the 1,000th and the 2,000th ship. Now it's just tragedy. A tragedy written in steel and fire and the cold mathematics of attrition. The Americans fixed their weapon, and the Japanese paid the price. December 1944. Pearl Harbor Submarine Base, Admiral Lockwood's office. The walls are covered with maps, each studded with colored pins representing sinkings, red pins for merchants, black pins for warships, white pins for submarines lost. There are hundreds of red pins, dozens of black pins, 52 white pins. Admiral Charles Lockwood stands before the map, a glass of whiskey in his hand. Beside him, Commander Dick O'Kane, recently awarded the Medal of Honor, studies the patterns. "We've sunk over 2,000 Japanese ships," O'Kane says quietly. "More tonnage than the rest of the Navy combined." Lockwood nods. "The submarine force represents less than 2% of the Navy's personnel, but we've accounted for 55% of Japanese maritime losses. And we've lost 52 boats. 52 boats, 3,500 men. They stand in silence, honoring the dead. Then Lockwood raises his glass. To the men who went out and didn't come back, and to the weapon that finally worked." They drink. O'Kane sets down his glass. "Admiral, what did we learn from this? What does the torpedo crisis teach us?" Lockwood considers the question. "It teaches us that institutional arrogance kills. Buord refused to admit the Mark 14 was flawed because admitting failure meant admitting they'd sent men to die with broken weapons. They chose bureaucratic pride over human lives. And it teaches us that the warriors, the men doing the fighting, are often right when they say something's wrong." Submarine commanders reported torpedo failures for 18 months before anyone listened. We ignored them because they weren't engineers, weren't bureaucrats, weren't part of the institutional priesthood. O'Kane walks to the map and touches one of the white pins. "The Wahoo, Mush Morton, lost with all hands, October 43. "I know. He died 3 months after we fixed the depth control. 3 months. If we'd listened sooner, hundreds of men would still be alive." Thousands of Japanese ships would have been sunk earlier. The war might have ended 6 months sooner. Lockwood drains his whiskey. But we didn't listen. We trusted the institution instead of the evidence, and we paid for it in blood. The deeper truth. The Mark 14 torpedo crisis represents more than a mechanical failure. It represents a philosophical failure. 2 systems, 2 ways of thinking, collided in the Pacific War. On one side, the Imperial Japanese Navy, built on tradition, hierarchy, and the belief that spirit could overcome material deficiency. Japanese torpedoes were excellent. The Type 93 Long Lance was arguably the best torpedo in the world. But Japan couldn't build enough of them, couldn't replace losses fast enough, couldn't adapt quickly enough. The Japanese system valued honor, tradition, and obedience above pragmatic adaptation. On the other side, the United States Navy, built on industrial capacity, technological innovation, and, eventually, the willingness to admit mistakes and fix them. American torpedoes were initially terrible, but America could build thousands of them, could test them to failure, could redesign them in weeks, could distribute fixes fleet-wide in days. The American system valued results over face, adaptation over tradition, engineer feedback over institutional pride. Eventually, it took 18 months of failure, but the American system finally worked. The German comparison. It's worth noting that Germany experienced an almost identical torpedo crisis. The German Navy's G7E torpedo suffered from the same problems as the American Mark 14. magnetic exploders that detonated prematurely or failed completely, depth control problems that caused torpedoes to run too deep, contact exploders that failed on oblique hits. The German submarine force reported these problems in the first weeks of the war, September 1939. The German Naval High Command initially dismissed the complaints. Then, in early 1940, German submarines attacked British warships in Norwegian fjords with perfect setups and zero results. The torpedo failures were so catastrophic, so public, and so embarrassing that Admiral Dönitz, commander of the U-boat force, personally intervened. He demanded immediate testing. The tests confirmed the failures. The magnetic exploder was deactivated. The depth control was recalibrated. The contact exploder was redesigned. By mid-1940, 9 months after the war began, German torpedoes worked. By contrast, American torpedoes didn't work until mid-1943, 18 months after Pearl Harbor. Why the difference? Germany's military structure allowed field commanders like Dönitz to override bureaucratic resistance. America's structure required bureaucrats in Washington to admit fault before changes could be made. The American system was more democratic, more distributed, more resistant to autocratic decision-making. But it was also slower, more conservative, more protective of institutional reputation. In this case, that conservatism killed thousands. The industrial philosophy. But once the Americans fixed the torpedo, something remarkable happened. The fix wasn't limited to a few boats. It wasn't rolled out gradually. It spread across the entire fleet in weeks. Every submarine received updated depth settings. Every submarine received redesigned contact exploders. Every submarine received new tactical guidance. And every submarine became deadly. This is the American advantage. Not that American equipment is always superior. Not that American tactics are always innovative, but that American industry, once pointed in the right direction, becomes unstoppable. Germany built 1,162 U-boats during World War II. America built 228 fleet submarines. But American submarines sank 1,392 Japanese ships totaling 5.3 million tons. German U-boats sank 2,779 Allied ships totaling 14.1 million tons. But they faced the combined industrial might of Britain, America, and Canada. The American submarine campaign was more efficient, more lethal per boat, and strategically decisive. Japan's merchant marine was destroyed, her economy collapsed, her military starved, all because American engineers finally admitted their weapon was broken and fixed it. The tactical evolution. The fixed torpedo enabled tactical innovations that would have been impossible with the defective weapon. Wolf pack tactics. Multiple submarines coordinating attacks on the same convoy, overwhelming escorts with simultaneous strikes from multiple directions. Surface night attacks, using radar to detect convoys at night, then attacking on the surface at high speed, exploiting the fact that Japanese escorts lacked effective radar. Ultra-intelligence integration, using decoded Japanese signals to position submarines along convoy routes, creating ambushes that appeared almost prescient. Lifeguard duty, submarines stationed near Japanese-held islands to rescue downed American air crews, demonstrating confidence that submarines could operate in hostile waters with relative impunity. Mine-laying operations. Submarines laying mines in Japanese harbors and shipping channels, creating psychological terror as Japanese ships were sunk by invisible weapons in supposedly safe waters. None of these tactics were possible with a 10% hit rate and a 40% dude rate. But with working torpedoes, American submarines became the most lethal weapons system in the Pacific theater, more lethal than B-29 bombers, more lethal than carrier strikes, more lethal than surface engagements, silent. Invisible, inescapable. The moral question. By 1945, American submarines were sinking Japanese ships faster than they could be replaced, merchant ships carrying civilians, refugee ships evacuating women and children from combat zones, hospital ships, though these were generally avoided when properly marked. The line between military and civilian targets blurred. Some submarine commanders struggled with this. Others did not. Commander Eugene Fluckey of the USS Barb landed a shore party in Japan and blew up a train. Commander Lawson Ramage of the USS Parch surfaced in the middle of a convoy and fought a running gun battle on the surface, sinking multiple ships with deck guns. Commander Sam Dealey of the USS Harder hunted destroyers with the same cold efficiency that destroyers hunted submarines. These were not defensive actions. These were not desperate measures. These were calculated, systematic, industrial-scale destruction. The submarine campaign was total war. And total war does not spare the innocent. The Japanese perspective. In post-war interrogations, Japanese naval officers were asked about the submarine threat. Admiral Yonai Mitsumasa, former Navy minister, said, "I think the submarine attack was most effective. I think it shortened the war more than any other single factor." Captain Atsushi Oi, a staff officer who analyzed convoy losses, wrote, "The submarine was the key weapon in strangling Japan. We could not move supplies. We could not feed our people. We could not fuel our ships. The Americans built a noose of submarines around Japan and slowly tightened it until we suffocated." These were not statements made in anger. They were statements made in resignation. The Japanese understood what had happened. They understood that American submarines, once a joke, had become the instrument of their defeat, and they understood that the fix to the Mark 14 torpedo was the turning point. The institutional reckoning. After the war, the Bureau of Ordnance faced no formal consequences for the torpedo crisis. No officers were court-martialed. No careers were destroyed. The institutional failure that killed thousands was quietly absorbed into the bureaucratic memory. But the submarine force remembered. And they made sure the Navy remembered. The Mark 14 torpedo crisis became a case study in naval education. It became shorthand for institutional arrogance. It became a warning. Trust the warriors, not the bureaucrats. Test weapons in combat conditions, not just laboratories. Admit failures early and fix them fast. Institutional reputation matters less than operational effectiveness. These lessons, paid for in blood, shaped American naval doctrine for decades. The legacy. The Mark 14 torpedo, once the most hated weapon in the American arsenal, became the most feared weapon in the Pacific. After the war, the design was refined and updated. The Mark 48 torpedo, still in service today, traces its lineage directly back to the Mark 14. But more importantly, the Mark 14 crisis established a cultural precedent. When the F-4 Phantom fighter jet showed deficiencies in Vietnam, the Navy fixed it quickly. When the Aegis combat system had software problems, the Navy tested it to failure and corrected the issues. When the Ford-class aircraft carrier experienced technical problems, the Navy acknowledged them publicly and worked to resolve them. The modern U.S. Navy is not perfect, but it is pragmatic. It admits failures. It learns from mistakes. And it does so because men like Charlie Lockwood, Dan Daspit, Mush Morton, and Dick O'Kane fought not just the Japanese, but their own Navy's institutional pride. They demanded that their weapons work. They refused to die for bureaucratic convenience, and they changed the culture of American naval warfare. August 15th, 1945, Tokyo Bay, USS Missouri. The war is over. Representatives of the Empire of Japan stand on the deck of an American battleship, signing instruments of surrender. General MacArthur presides, somber and formal. Admirals Nimitz and Halsey stand nearby, representing the Navy that broke Japan's back. But there are no submarine commanders present, no admirals from the submarine force. The silent service remains silent, even in victory. Below deck, USS Archerfish. Commander Joe Enright sits in the wardroom of his submarine, listening to the surrender broadcast on the radio. He thinks of the Shinano, the massive carrier his boat sank in November 1944. He thinks of the convoys destroyed, the tankers burning, the destroyers broken. He thinks of the 52 boats that didn't come home. The voice on the radio announces the formal end of hostilities. Enright turns off the radio. The silence is profound. Pearl Harbor, Admiral Lockwood's office. The maps are still on the wall. The red pins, the black pins, the white pins. Lockwood removes them, one by one, carefully, reverently. Each pin represents a ship. Each ship represents men. Some American, most Japanese, all dead because of decisions made in offices far from the fighting. Some good decisions, some catastrophically bad decisions. He reaches the white pins last. 52 submarines, 3,500 men. How many could have been saved if the torpedoes had worked from the beginning? He'll never know. But he knows this. The men who died didn't die because the enemy was superior. They died because their own weapons failed them. And then, once the weapons worked, they won. Completely. Overwhelmingly. Inevitably. Imperial Japanese Navy Headquarters, Tokyo. Commander Takeo Nakamura, the intelligence officer who laughed at American submarines in December 1941, sits in a ruined office, staring at the final tally. Japanese merchant marine losses, 1941-1945. Ships sunk, 2,346. Tonnage lost, 8,618,109 tons. Percentage sunk by submarines, 60%. Percentage of pre-war fleet destroyed, 88%. He remembers his words, spoken with such confidence 4 years ago. Their torpedoes are toys, defective toys. He was right, they were defective. For 18 months, they were defective. But then the Americans fixed them, and the joke stopped being funny. Nakamura lights a cigarette. His hands shake slightly and stares at the numbers. 8 million tons. The entire merchant marine erased. Japan's oil imports down 95%. Steel imports down 90%. Food imports down 75%. The home islands starving. The Navy immobilized. The Army isolated. All because American submarines, once dismissed, once mocked, became instruments of total economic warfare. He exhales smoke and closes the report. Outside, Tokyo is rubble. The factories are silent. The harbors are empty. They laughed when they saw the American torpedoes fail. They stopped laughing when the torpedoes started working, and then there was nothing left to laugh about. The final numbers. The Mark 14 torpedo, once it was fixed, sank. 1,392 Japanese merchant ships, 214 Japanese naval vessels, including 1 battleship, 8 aircraft carriers, 15 cruisers, 42 destroyers, 23 submarines. Total tonnage, 5.3 million tons. The cost, 52 American submarines lost, 3,505 submariners killed. The ratio, 1 American submarine for every 26 Japanese ships sunk. The strategic result, the Japanese economy collapsed. The thunder speaks. There's a saying among submarine veterans, the submarine that sank you, you never heard coming. But that's not quite true. If you were on a Japanese merchant ship in 1944, you did hear it. You heard the high-pitched whine of the electric motor. You heard the rushing water as the torpedo cut through the sea. You heard the metallic clang as it struck the hull. And then you heard the thunder, the roar of 643 pounds of Torpex detonating against steel, the shriek of metal tearing, the rush of water flooding compartments, the screams of men trapped below. That sound, the sound of a working Mark 14 torpedo, became the soundtrack of Japan's defeat. It played in every shipping lane, every coastal route, every convoy formation. It played until there were no more ships to sink, until the merchant marine was a memory, until the empire was strangled into submission. The men who designed the Mark 14 torpedo never intended it to be defective. They were engineers, not saboteurs. They believed in their work, trusted their calculations, assumed their tests were adequate. They were wrong, but they were also, eventually, willing to admit it. And that willingness, that capacity to acknowledge failure and fix it, is what separates free societies from tyrannies. Japan built a perfect torpedo, the Type 93, and never had enough. America built a broken torpedo, the Mark 14, and fixed it. Then built 10,000 more. That's the difference between engineering excellence and industrial supremacy. That's the difference between a warrior culture and a learning culture. That's the difference between honorable defeat and pragmatic victory. Epilogue. The Silent Service. Today, American submarines patrol the world's oceans. Nuclear-powered, missile-armed, capable of remaining submerged for months. They carry weapons that would have been incomprehensible to the submariners of World War II. But they carry something else too. A memory, a lesson, a warning. Your weapon must work. When you pull the trigger, when you launch the torpedo, when you commit to the attack, your weapon must function. Because if it doesn't, men die. Not the enemy. Your men. The Mark 14 torpedo crisis is taught at the Naval Academy. It's taught at the Naval War College. It's taught to every submarine officer who pins on dolphins and takes command of a boat. Trust your crew. Test your weapons. Fix your failures. Learn or die. Commander Takeo Nakamura died in Tokyo in 1963, 18 years after the war ended. He never spoke publicly about the submarine campaign. But in his personal papers, found after his death, there was a single handwritten note, dated August 16, 1945, the day after the surrender. It read, "We laughed at their broken torpedoes. We were right to laugh. But we should have been afraid, because once they fixed them, nothing could save us. Not our skill, not our courage, not our spirit. They simply drowned us in working weapons and industrial capacity. We fought warriors. They fought with factories. The factories won." The thunder spoke, and the sky, once the domain of the rising sun, belonged to someone else. The sea, too, the sea especially. Because beneath the waves, silent and patient and merciless, the submarines hunted. They hunted with torpedoes that worked, and they didn't stop hunting until the war was over, until the merchant marine was extinct, until the empire surrendered, until the laughter died. And the thunder, the terrible thunder of a working weapon in the hands of determined men, faded into history. But not into memory. Never into memory. Because the men who fixed the Mark 14 torpedo saved the submarine force. And the submarine force won the Pacific War. One working torpedo at a time.